So what does it mean when net work is positive, net work is negative? Using the same picture. Again, the same situation. We want to figure out what it means when the net work is positive and the net work is negative. So to do that, we want to figure out how we can calculate the net work. And we can look at it in three different ways. One way of calculating the net work is to sum all the work. So from the previous example, we had 4 forces doing work. So if we were going to add the work done by all the forces, it would be the work done by F plus the work done by Fk plus the work done by N plus the work done by Mg. What did we have? Positive F delta X plus negative Fk delta X plus 0 plus 0. So the net work is F delta X minus Fk delta X. That is the amount of the negative net work. And if we want, or the net work. And if we want to, for this problem, we can factor out a delta X. So here's the net work again. F minus Fk delta X. So let's look. If F is bigger than Fk, looking at our picture, what does that mean? If F is bigger than Fk, that means the net force is acting to the right, so the object speeds up. Right? So now I know that the object speeds up because I'm analyzing all the forces. So if the object speeds up, okay, if F is bigger than Fk, the net force is positive, therefore net work is positive. So thinking about what that means, if the net work is positive, the object speeds up. If F is less than Fk, that means it's still moving to the right, but slowing down. The object slows. Net force negative. So the net work is negative. And all that means is if the net work is negative, the object slows. If F equals Fk, we can't say it's not moving because it is moving. That's constant velocity. The net force is 0. Therefore, the net work is 0. It doesn't mean no forces are doing work. It means the total amount of work by all the forces is 0. So looking at it, net work is 0, net force is 0, constant velocity. There are other ways of calculating net work. You will end up with the same answer. We just want to look at the methods. So 1 is to add up the work done by all the forces. 2, we could think about net work is going to be equal to the net force cos theta delta x. So we could find the net force cos theta delta x. So in this case, what do we have? Net work equals net force. And really, we could just write delta x because if we find the net force, the sign will come out in the wash. And in this case, it would be F minus Fk delta x. The same analysis is going to occur as we just looked at. The third way of getting net work is by using this formula. Thinking about net force equals MA, we can replace sum F by MA. Net work equals, if it's sum F delta X, MA delta X. This is a short equation, but it doesn't mean it is easy to use. In practice, as we've always talked about, A is not necessarily an easy thing to find. However, this formula may help us derive another formula later. So there are three ways of calculating net work. The work done by each force, the net force times delta X, or MA delta X.